So I wanted to take a little bit of time to talk about proofs. Now, I'm not really going to go into, all the technical jargon, converse, contrapositive, because those are all valid and you definitely should know them. But for the people first entering real analysis, I think it's important to kind of just remember like what you're going to be doing. Because, in calculus and pre-calc and algebra, you were asked questions to kind of solve for things, if that makes sense. What is the solution to this equation? What is the derivative of 3x? What is the integral of sine? Stuff like that. You're asked to solve for things. In real analysis, what you're mostly going to be doing is proving things. And this is completely different. This is not the same thing. So you need to forget everything you did in calculus. Because yes, the concepts are the same, but what you're going to be asked is completely different. So what does proving things actually mean? So that is a fantastic question, and it takes a while for people to figure out. But like I said, this is not going to be these plug and chug formulas most of the time. Yes, there are certain processes you can do, but proofs are interesting in the fact that you're basically writing an argumentative essay or a logical essay detailing what you're assuming is true and trying to prove a certain conclusion. So yeah, the two ways that I would say you should approach proofs are start with what you're assuming to be true, and then work your way, manipulate that using rules addition, subtraction, multiplication, division. Or start with something that gives you the result you want and reduce it down to something that you do know. So that is kind of basically what you're going to be doing when it comes to proofs. You're not going to be answering these direct questions. You're going to have to show why something is true. And a lot of people don't have experience with that, especially coming into real analysis. So the good thing, though, about proof writing is when you get good at it. No, I'm not saying I'm good at it because obviously the real analysis course I took was an intro, and you can get crazy analytical stuff, but you're going to see that your critical thinking and analysis skills increase so much when you take real analysis. You'll be able to look at problems in real life that aren't related to math at all and be able to work your way through them and logically deduce certain conclusions better than you would have before. At least I experienced that. I noticed in my everyday life, I could think calmer, I could think more plainly, and that is honestly the advantage that real analysis has. It's basically a logic writing persuasion class in the realm of math. Now, okay, once you understand that you're proving stuff, not asked to do things, you're proving something is true, what should you do? Well, obviously, the best thing you can do is practice. So, maybe get a proof book, learn what it means to prove by contradiction, prove by contrapositive, a direct proof, so on and so on and so forth. Well, I guess I could give a little spiel on each of those. So, direct proof is what I said before. You're either, assuming something is true and manipulating it down all the way through to see... manipulating all the way down to try to get a certain conclusion. So, for example, let's say multiplying two even numbers always gives you an even number. Well, then your first question should be, that's the proof we're going to be asked. How do you write that? Well, you just say an even number is equal to 2 times some integer. Let's call it A. And another even number is going to be 2 times some B. So when you multiply 2A times 2B, you get 4AB. Well, AB is an integer, and 4 is 2 times 2, so you could write that as 2 times 2AB, which 2AB, if you let that be another integer, L, 2L, therefore it's always even. So that's an example of a direct proof. Proof by contradiction is basically saying, if we assume something is true, and we do all these logically deducing steps, are we going to get something that doesn't make sense? Like in the famous square root of 2 proof, you basically get that both, if you assume square root of 2 is rational, both the numerator and denominator share a factor of 2, but that's impossible because we claim that they didn't share a common factor. So they can't be even and not share a common factor, if that makes sense. And then finally is contrapositive, which is really powerful and it's used a lot. Basically, if you have like, like, what is it? If it rains, I use an umbrella. It would be like, if I don't have an umbrella, it won't rain. So it's like kind of like the opposite, like the counter positive. So that is what I wanted to talk about for proofwriting, for real analysis at least.